So, hello and welcome to our today's webinar with the topic WS sensor family. So we will start today with the modular concept of the WS family, and we will discuss some different points during this presentation. For example, we will discuss the advantages of the UMB technology regarding the WS family. We will also talk about the different measurements and the measurement principles of the WS sensors. We will discuss the electric connection wiring of the WS sensor as well. We will talk about the use of the UMB Config Tool together with the WS sensor. And at the end I will show you some application examples where the WS sensors are used. Okay, so the presentation today will be more, let's say, more technical, and yeah, you will see. First of all, the base of the WS sensors is, of course, the UMB technology. UMB means Universal Measurement Bus, which is a special protocol used to communicate with the different sensors, right? It's based on RS-485, but the protocol itself is a different one. First of all, I also want to inform you that, of course, you can also ask questions. That means you can use the question function on the right side of the menu to enter some questions. And we will have some breaks during the presentation where we will answer your questions, of course. All right? So right on the right side, the questions window, you can enter the questions there, and then we will have some breaks, and then we will talk about these questions. First of all, here we have a picture with the, let's say, modular family of the WS sensors. If you check here, the definition of this sensor is the intelligent measurement devices using UMB technology designed for a variety of applications, of course. Because if you check the family here on the picture, on the right side, you have, for example, the smallest WS sensor, which is a WS200, and on the left side, you see the WS600 and 601 with more possible measurements in the device itself, right? We will talk about this in a few minutes anyway. So, which are the advantages of the UMB technology? First of all, we have this compact design, right, for real-time weather station. That means I will show you that live here on the camera. This one is such a WS600, for example, and you see that we have all the different measurements in one housing. Yes, so that's the compact design of the real weather station, right? Then, of course, it is easy to install because it's only one sensor. So you don't need to install different sensors on the pole. It's always normally one sensor which you have to put on the pole. And, of course, also easy commissioning. For all the UMB sensors and, of course, also for the WS sensors, we use one software protocol, which is called UMB protocol. I told you that a few minutes before, right? Which means Universal Measurement Bus. So all the different UMB sensors will communicate with each other with this bus, and they can all talk to each other, right? Then we have one hardware interface which you normally can use, which is called the ISOCON. I will show you that also here in the cam. So this is the ISOCON normally, which you can use to communicate or to connect to the WS sensors. So the ISOCON has one RS-232 port, so you will be able to connect some modems, GPS modems, or COM servers or something like that, right? And you have the connectors here, two connectors, to connect the WS sensor directly to the ISOCON. This ISOCON normally is a converter which converts the original RS-485 signal of the WS into RS-232. So one special thing of the WS sensors is that all the calculations will be done directly in the WS sensor. So that means normally we will do an analog measurement of the different values, and all the calculations will be done inside a housing. That means there is a microprocessor on the main board which will do all these calculations. After that we will transfer the data, that's the second point, via digital interface to the PC or to the cloud or something like that, right? So the WS sensor has a digital interface to transmit the data. So normally only 2 wires are necessary to transmit the data in this case. After some, let's say, discussions with our customers, we recognize that UMB binary protocol, which is the standard protocol of the WS sensors, is not the only very important protocol which the customers normally use. So we have also integrated all the other important protocols which you can configure on the WS if necessary. We have implemented 3 additional protocols, which is ASCII UMB, Modbus, and SDI12. For your information, if you order a WS, the standard configuration will be UMB binary. So that will be the standard configuration of a WS sensor. So if you want to change the protocol, you need to do that with a special software called UMB Config Tool. The next point is the firmware update via RS-232 or RS-485. So also this is of course a very important feature, because like I told you, we have a microprocessor running on the WS, and sometimes we have some updates. That means we have some additional channels which we will integrate, or we have some bug fixes of the firmware itself. And so firmware update is really, really necessary and important. For that reason, you will always be able to download the actual firmware on our homepage. So always, please check always our support section on our homepage, because there you will find all the actual firmware versions of the WS, and of course also for all the other UMB sensors. The firmware update can be done with a tool, and that's the UMB Config Tool. That's the one software tool for all sensors. And this UMB Config Tool will be also downloadable on our homepage. With this tool, you will be able to do the firmware updates if necessary, and you will be able to configure the WS, and you will be able also to show some actual value on the screen. Anyway, we will see that later, because I will do let's say a general introduction of the UMB Config Tool in a few minutes. So these are the advantages of the UMB technology, right? Now I want to show and talk about the measurement principles with you, right? And as an example, I will show you the measurement principles of a WS600 here, right? And we will start with the first level. And on the top of the sensor, you will see the couple, which is a plastic couple, and inside this couple, there is a Doppler radar sensor inside. I will show you that live here. So here we have, the couple, and inside the couple we have the radar sensor placed, and this radar sensor will measure the precipitation. So how is that be done, right? So we have here let's say the definition of the measurement principle itself. It's a 24 GHz microwaves-doppler radar, which measures the precipitation type and precipitation intensity by the correlation of drop size and drop speed. That means we can measure the drop speed, the velocity of the drop, and the size of the drop. And with this information, we can calculate the amount of water in one drop. And so we can, of course, sum up the water, and then we will know the quantity of precipitation, right? That's how it works. And that's for the quantity and, of course, for the intensity. The type is a different thing. So if you want to know the precipitation type, for that we use only the speed. That means the frequency of the speed, how the precipitation will fall down on Earth. And if you check here the first diagram here, which is called rain, you will see that if you measure the normal, let's say, velocity of the raindrop which comes down to Earth, it's normally lying in the middle between 4 meters per second here, right? And that's, let's say, the threshold where the sensor knows, okay, if there is precipitation which comes down with 4 meters per second, it must be rain, and so you will get the information it's raining. Same thing for snow. If you look on the snow table on the right, you will see that the snow flake will fall down here normally, typically with 1 meter per second. And that's what the sensor knows. So he knows, okay, it's 1 meter per second, around 1 meter per second, it must be snow. And so you get the information, it's snowing, right? So that's how it works. One important thing here is, of course, the sensor not only measures the precipitation in reality, the sensor itself, the radar sensor itself, measures also different other velocities. And so it is important, or what is important in this case, is the installation of the sensor itself. That means, for example, if you install the sensor beneath a tree and the breeze starts to wave in the wind, of course this will influence the measurement, and the sensor will think, okay, it's raining or it's snowing. So it's clear that if you install a sensor, you have to check our installation guides, because normally around 10 meters, in a diameter of 10 meters around the sensor, normally there should be no plants and nothing which will move, right? So that the sensor can really only detect the precipitation. That's very important. Another important thing is the sensor itself is heated. That means the top of the sensor, here again, top of the sensor is heated. And this is needed because, of course, during winter time, we don't want to have some snow or ice on top of the sensor, because if there is some snow or ice, the sensor will not measure anymore. That's one reason. But the other reason is that normally it's also heated during summertime. The reason is that the radar sensor itself has a working point, and this working point and temperature lies at 70 degrees. So we have to heat the sensor also up during summertime to get the best performance, right? All right, that's what I want to show you about the precipitation sensor. Then we move to the next level. The next level is the wind speed and wind direction measurement. And for this measurement we use ultrasonic sensors. We have 4 ultrasonic transducers placed on the WS600 here, and all of them can send and receive this ultrasonic beam, right? It's a receiver and also transmitter. What we do here is, the measurement principle is that we will measure the time of the ultrasonic beam from one side to the other. And with the influence of the wind, this time will be changed. And this change of time can be calculated into a wind speed. That's how it works. The same thing for the wind direction. So I can show you that again on the monitor. So if you see, here we have the wind transducers, and the beam will be moving from here to the other side, and with this time we can calculate the wind speed. For the wind direction, it's the distortion of the beam, right? So depending on the distortion angle, we can calculate the wind direction. But of course it's also clear that the sensor itself cannot know the right position of the direction. That means where is north, where is south. So for that reason, before we do the installation, we have to put the sensor really to north. And maybe I can show you here, there is the marking for north. You can see that here. It's placed here on top. And so what you need to do is, during the installation, you have to put this marking to north. Normally you can use a compass to do that, right? So that's really important, because if you do not do that, then the wind direction value will not be the right one. So what are the advantages of this type of measurement? Of course, we have a low startup value. That means if you compare that with a mechanical anemometer, you know that there are some mechanical parts inside, and a mechanical anemometer needs a minimum wind speed to start to turn. And that's of course not the case with ultrasonic sensors. So they will start with 0.1 meter per second to give you these values. This is a big advantage. It's maintenance free, no mechanical parts. Normally you don't need to change something here at the sensor, and it's very precise, of course. Heating. Also this sensor part is heated. And in this case it's only heated because of the winter influence. That means it's regulated with the temperature. Normally it starts under 5 degrees to heat up. And we will heat up, again I will show you that. The only thing which will be heated up are the transducers itself. So that means these parts here. This one, this one, this will be heated up. Alright, so that's the part of the wind measurement. Then we have on the main board, we have an air pressure sensor and an internal compass. So this is placed again here. It's placed here under this plastic cover. There you will find the main board of the sensor itself, and on the main board we have placed these small sensors. That means the air pressure sensor and the internal compass. Talking about a pressure sensor, you will have the possibility to use two different values. That means you can use absolute air pressure, which is always the pressure which is calculated to 0 Z level, and you will also be able to get the relative air pressure, which is always calculated to the real height of the station. If you want to use the relative air pressure, it's clear that you need to enter the real height of the station into the WS microprocessor. This will be done with the UMB Config Tool. So that's a must if you want to have the real relative air pressure measurement. Then we have an internal compass now inside the sensor itself, and this internal compass is a new one. And with this compass you will be able to adjust the sensor to the internal compass. That means if you activate this compass, you can do the calculation of the wind direction compared to the compass or linked to the compass. So you don't need to put the sensor to north in this case if you activate this function, right? Alright, that's the compass and the air pressure sensor. Now we move to the temperature humidity measurement, and you will see on the housing side that we have here we have the radiation shield, and under the radiation shield you see that here in the middle there is a tube which leads into the radiation shield, and in the middle of the radiation shield with in this tube we have the temperature humidity measurement elements. And for the temperature we use here an NTC, which is a resistor which changes its value depending on the outside temperature. And for the humidity we use a capacitive sensor element which changes its capacity depending on the humidity outside. The two sensor elements are covered with a special cap, with a Teflon cap, to secure the sensors against dirt and dust. Also, what is a special thing of the WS sensor here, we use, or we have implemented also a ventilated aspirated radiation shield to cool down the temperature measurement to the real outside temperature value. So I can show you that again here. From this side you will see here, this is the fan, so that's the ventilation of the radiation shield. Alright, so at the end we have also the communication, and you know, I told you that we have normally RS485 communication type for all the WS sensors, and with this communication interface you will be able to communicate without any amplifier with a length of 1200 meters. But that's only information for the two communication wires. We are not talking about power supply. Power supply, of course, cannot be extended to 1200 meters because you have the power drop here. So the maximum length with this type of wires we use normally for the WS sensor, it's the maximum length for the power supply is 40 meters. 40 meters for the power, 1200 meters for the two communication wires. And of course we have these different protocols: ASCII, SDI12, Modbus, and UMB. Alright, so that's it. One special sensor here I want to show you is also, of course, the WS501. Normally this sensor has the same measurement principle, but you see on the top we have a different sensor installed there. So we have no precipitation sensor here, we have a special thermopile pyranometer which measures the global radiation, and this one is normally the type of the WS501 is a Kip-Enzonen CMP3, which is integrated here, and this one will give you the value of the global radiation between 0 and 1400 watt per square meters. You can also get a Luft pyranometer, so this type is called WS502 or 302, and which is a Luft pyranometer, not from Kip-Enzonen. So that's the thing I want to show you also as an additional sensor. Questions. So if you have some questions, please, you can ask them and put them into the question box if you want. I will wait now maybe 10 seconds. After that we'll go on if there are no questions. Okay, I think there are no questions until now, so we will go on, right? So this is the connection. I want to show you how we will normally connect the sensor, and you see that it's really easy because normally there are not so many wires. Oh, there is one question now coming in. So maybe we can go back to the question section, right? So how is the rainfall typically expressed? So normally if you talk about the WS sensors, you will have the possibility to get values for the quantity. That means a differential value. That's always the sum in a time period. That's the typical way to express rain. So that means normally it's linked to the readout time, to the polling time. That means if you poll every 10 minutes, okay, in millimeter per square meters, no, it's time period. That means normally it's only millimeter or liter per square meters. That's not the typical unit, and it's always depending on the polling time. That means if you poll the sensor every 10 minutes, the sensor will sum up the precipitation for this 10 minutes. For example, 1.5 millimeters or liter per square meter, which is the same, only a different unit. And then you will get transmitted this value, and the sensor will set back the original value to 0 and start again to sum up. After 10 minutes, again, he will transmit the data and again set back to 0 and so on. That's how it works normally. The same thing for the precipitation type. Also the type will be transmitted and of course registered during the time period. That means 10 minutes, the sensor will check the velocity and will give you the information if it's raining, if it's snowing, or if it's dry. After 10 minutes, he will start from 0 and check again what happens during this time period. That's how it works. Okay? So, of course, let's go on. Wiring. Connection of a WS600 here, but the connections are all the same for all the different WS sensor types, right? So we have 6 wires in this case. We have 2 wires for the power supply, brown and white. These are always the wires for the power supply. Brown is plus 24 volt, white is ground. Always the same. Then we have 2 wires for the communication. Also these wires are always the same. We have green wire for RS485A and yellow wire for RS485B. Always the same. These are the 4 standard wires. If you connect these wires, the sensor will work for sure. Then you have 2 additional wires, extra wires for the heating. That means you need to power up the heating extra. And for the heating we have the wire red, which is plus 24 volts, and blue, which is ground. So you have to connect the power supply wires extra. Don't forget it. Because if you don't connect them to the power supply, the heating will not be switched on. So that's how it works. Normally, you see that at the bottom, you connect the WS to an isocon with the 4 wires. So 2 wires for the power supply, 2 wires for the communication. You will power up the isocon extra, and that's it. After that, you will be able to connect the RS232 port of the isocon directly to the laptop or to modems or to COM servers. I will show you that live again here. So we have this small installation here, and this is the power supply. We have 230 volts here or 110 volts here on this part. We have 24 volts output on this part. With the 24 volt output, we go to the bottom connector of the isocon. So the complete isocon will be powered, and also in this case with the wires here, power wires of the WS cable, this is the WS cable here, and with the communication wires here, could also put them out, you will be able to power up the complete station. And if you look here on the wire, I think you can see it. I put together the red and the brown. Red and brown for plus 24 volt. That means you can also get the power supply for the heating from this connector. So put together red, brown and white, blue, and then everything is powered. The electronic part and also the heating part. And after that, here on the RS232 port, you will be able to communicate with the station. Okay, that's the wiring of the sensor itself. Then we have an extra here. Maybe you know that we have the possibility to connect external probes to the sensors, to the WS sensors. And now I will try to explain you which external sensors can be used with which type of WS, right? So this is the extension WS sensor with external probes. And the first probe I want to show you is the external temperature probe. And this probe will be able to be connected to all WS sensor types. So for all WS sensors, you will be able to connect this type of sensor. That's the temperature, external temperature probe WT1, and this will be connected with some special wiring. That means you have to put the wire, the main cable wire of the WS into the cabinet and the cable of the WT1 external temperature probe into the same cabinet, and then you have to link different wires together. I will show you which one. So again, you have the cable here, and normally two wires will not be connected. And these two wires are used to connect to external probes. That means the gray wire and the pink wire. The polarity is not important in this case with the temperature probe, because the temperature probe is also an NTC, and which is a resistance value, and so it's no polarities necessary. So you can connect the two wires from the external probe to one of these two wires here, and then you have to activate the measurement with the UMB Config Tool. That's all. So that's the connection of the external probe for all WS sensors. So you will be able, let's say, to extend the WS sensor measurements with one external temperature probe. Then we have again another one, which is a leaf wetness sensor. And this leaf wetness sensor is normally only used and connected to a WS401 and a WS601. 401, 601, right? And I will also show you how to connect this leaf wetness sensor. So you have the 601 here. You can open the funnel easily. And if you look inside, you have different connecting screws. And these connecting screws here, I will show you that with the screwdriver, here, here, and here are used to connect the leaf wetness sensor. You can enter the cable with here, and then you can connect them directly to the screws. That's easy. And of course, after the connection of the leaf wetness sensor to the WS601 or 401, you have to activate this sensor with the UMB Config Tool. So that's the leaf wetness sensor called WLW100. So also for agro stations, you will be able to create a full agro station type with the WS601, for example, and a leaf wetness sensor. And at the end, we will have the external tipping bucket. And this external tipping bucket can be connected to all WS sensors without internal precipitation measurement. That means WS500, 501, 401, and so on. No, not 401, of course, 301, 300. So all WS sensors without internal precipitation measurement can be connected to this external tipping bucket. Connection external tipping bucket, WTB100. That's the article number of this product. Also, this tipping bucket will be connected inside the cabinet. Inside the cabinet with the same wires. Again, we can use these two wires here, gray and pink. And the WTB will also have the same wiring colors or wire colors. So you connect together pink with pink from the tipping bucket, gray with gray from the tipping bucket. That's it. And then you have to activate this tipping bucket again in the UMB Config Tool. That's all. Questions? So I can see one question, can we get a presentation here? Yes, you can get a presentation, And you will also be able to get the complete video of this presentation. That means we will register the video or do a video of this presentation, and you can download that on our homepage in the future. So then we have another question. Confused to make the troubleshoot with UMB. Wait a moment. We will check first the new questions here. About the problem, no communication. I want a simple software to do the troubleshoot by one click. Clients are always confused. Make the troubleshoot be implemented inside the UMB Config Tool, like the calibration of the... So what do you mean with troubleshoot? If you get, normally if you get a problem, no communication, that's a hardware thing, you know. You cannot do a troubleshoot with the software in this case. How will you do that? There is no communication. How should then the software say to you what is the problem if there is no communication? So you have to check this problem in this case. So normally it's a power supply problem, it's a communication wiring problem, or the sensor is defective. So these are the two possibilities. We cannot implement that. That's not possible in this case. Because how should the sensor, how should the UMB Config Tool know which is the problem if he has no communication? So then the second question, what kind of information do I get from the wet leaf sensor? Yes. Something like dry, most wet? No. You will get the voltage, the real voltage output, that's one thing, and I think you can also get, of course, yes, the information for dry, moist, and humid. That's it. And that's the standard information which you normally get from a leaf wetness sensor, right? So the distances are the distance between external probes and WS. The maximum or the standard distance is 10 meters. That's the standard distance for the NTC. That's the standard distance for the tipping bucket, and that's the standard distance, I think, for the leaf wetness sensor. 10 meters. Then if it's possible to power with 12 volt DC, yes. WS sensors have a big voltage range between the new ones, between 4 and 40 volts. That's the new version. The standard version, the old version, was between 9 and 30 volts, but I think we extended that now between 4 and 40 volts. So that's the possible voltage which you can put on the WS sensor. So we have another one, client modify the ID. That's the question. Troubleshoot. Client modify the ID baud rate. Yes. So the troubleshoot here is very easy. Hayun, you asked that, right? The troubleshoot is very easy because if the client changes the ID, the baud rate, or also the protocol, I do not know if you know that we have a security mode now, and the security mode now will, after power reset of the WS, that means if you power off and on the WS for the first 5 seconds, all the WS will run or start up with the standard configuration. So if you have a changed ID, if you have a changed baud rate, and if you have a changed protocol, that doesn't matter, because then the sensor will run or start up with ID 200, baud rate 90,200, and UMB binary for the first 5 seconds. And within the first 5 seconds, you will be able to connect with the UMB Config Tool. And if you connect it with the UMB Config Tool after the first 5 seconds, then the sensor will stay for 10 minutes in standard. And always you send a command with UMB Config Tool, it will again be extended to 10 minutes. And now in this mode, you will be able to change again the configuration. That's how it works. I know, but the client is not expert, yes, but you know, sorry, but that's the easiest way. What should we do? Automatic or what? That's not possible. That's the security mode is a real good mode. And it's a really easy mode. And normally you will be able, within 5 seconds, to get in touch with all WS sensors. And it's not depending on the configuration. I think that's really easy. The only thing you need to do, Hayun, is to show them how to do that. And then they will understand. I do that every day, 10 times a day here at my hotline. And that's really easy. They understand that. All right, so let's go on. We had the questions now, and so the next thing, or the next part, will be the UMB Config Tool. Here is a little description how it works with the UMB Config Tool, right? So on the left side you see the WS, again as an example it's the WS600 connected to an ISOCON. And from the ISOCON RS-232 port we connect with a standard RS-232 cable to a laptop or a computer. And after that we can start the UMB Config Tool. And that's the picture or the screenshot on the right side. That's the main menu of the UMB Config Tool, which you will see there. Anyway, I will show you that now live how to do it. I will not go into the deep thing of the UMB Config Tool because we have an extra video for that. If you need more information about UMB Config Tool, how to configure a WS or something like that, we have an extra video on our homepage for that. So please check that on our homepage. Now I will only show you the general features, how to go into the software, how to open it, how to get in touch with the sensor. I will show you that now in the next 5 minutes. So I will switch now to the screen, to the main screen here, and we will start the UMB Config Tool. So start a UMB Config Tool, and then we have this small menu here. Normally we start with Edit, and we need to know which connection was established. Normally it's a RS-232 connection, so you need to choose the right COM port. In our case it's COM1. After that you go back to Edit and say Sensors. And what we need to do now is, of course, the software does not know which type of sensor is connected to the UMB Config Tool. So we need to choose the right sensor. And that will be done here in this window, Type of Sensor. You can open that, and then you will find all the different UMB sensors which we have in our portfolio. In this case, I have installed a WS, and so you can choose WSx. X stands for all the different types. Choose that, and then you have to add it into the selected sensor list. All the sensors which are placed in the selected sensor list can be connected with UMB Config Tool. So you have to do that. You can do that also with the auto scan button. Using the auto scan button will do the same, but only automatically. But normally you will be faster doing that by hand, manually here, right? So now it's part of the selected sensor list, right? And if you want to know if it's really connected and if the communication really works, you will always be able to use the Verify button. So mark the sensor and click on Verify. Now you will get the status. In this case, it's Verify OK. And if you get a Verify OK back, then you know that the communication is working between UMB Config Tool, ISOCON, and WS. So everything on the electric side is connected the right way, and it will work. If you get an error here, so that means Verify not OK, then, or failed, it's called normally Verify failed, then you have to check the setup. That means check the power supply, check the wiring, check the ISOCON, and check the WS, because something is wrong. All right? So that's the first part. Now you want to configure something on the WS. If you want to do that, then you mark the sensor again in the selected sensor list, and then you go to the Configure button. And now you will be able to choose different things. Normally, you need to import the actual configuration of the WS. And in this case, you need to use the Load Profile from Sensor button here. Because first of all, we need to know the actual configuration. So strike this button, the actual configuration will be loaded, and you see you have now some different menus here. We have a main menu, that's the same thing like before. Then we have an info menu, and there you will find an important information. This is the firmware version here, which is installed on the connected WS. And you will always be able to check the actual firmware on the WS with this button, with this menu here. Then you get, of course, also the information of the serial number, the tested, when was the sensor be tested, and the project number, all this stuff. But the most important information here is the firmware version. And with this firmware version, you can choose if you want to do an update or not. And then you go to for the configuration, you click on the WSx UMB menu, and we have here 3 standard menu parts. And I will explain them. Only the standard menu parts. I will not go into the deep configuration later on. So the first menu part here on the left side are always the general properties. And the general properties, in this menu you will be able to change the ID of the station. And you can enter the description if you want. That's the general properties. On the right side we have the communication properties here. And this is an important menu because there you can change the line speed, the baud rate. You can change the protocol here, UMB ASCII, SDI12 Modbus. And you will also be able to change the timeout for protocol change. That's the time I told you before, I explained before. If you change or if you send a command in the first 5 seconds, then automatically switch on for the next 10 minutes. That's the communication properties menu. Then on the bottom you have the measurement setup. In this case it's a WS500 connected, and there you can do all the configuration of the measurements. I will not go into the deep now. I will not show you the different menus, but that's where you can do the configuration of the WS measurement values. Alright, if you have changed something, you go back to the main menu, and then of course you have to store the new profile on the sensor. And that you can do that with this button, Store Profile on Sensor. So never forget to store the profile after we have changed something on the sensor itself. Alright, so that's how it works. I will close now the UMB Config Tool, and we will go on with the presentation. So, all right, let's go on. Questions? So, if you have some questions, you can ask them now regarding the UMB Config Tool or something like that. I will wait some seconds. We already VDB sensor and cable. So again, you want to know how to connect to a PLC. That's easy. I showed you before. The cable of the WTB100 will be the same like the cable of the WS sensor. So that means these are the 2 wires which needs to be connected to the PLC. And also because the output of the WTB100 is an impulse output. And so that's really easy because the impulse output again has no polarity in this case. So where to connect these 2 wires is not important. So you can use these 2 wires, and then the impulse value will be transmitted to your PLC. Of course you have to configure your PLC for an impulse input, right? But that has nothing to do with our sensor. Our sensor will give you an impulse output. And you have to connect these 2 wires to your PLC and you will get the impulse. So we have an extra training anyway for this video for this WTB100. So you can watch our movie, our video on our homepage. And on our homepage we will have an extra section where you will see how to connect the WTB100, for example, to our WS sensors, and also how to connect it to a PLC, for example. It's really easy because you only need 2 wires. And these two wires, you don't need to check the polarity of these wires. You can connect them directly to the PLC. The only thing is that you need to configure your PLC, but that's not our work. That's the work of you, yeah. Because you can configure nothing on the WRTP100 because it's a standard impulse output. All right, so let's go on to the question, why modular? And the answer is really easy. Because each application has its own requirements. That's the answer. So that's the reason why we have this modular, this family concept here. Because every application is individually. And we do not know which one is needed for which customer. And so the customers with this modular concept will be able to choose the right sensor for the right application. And that's what we also answered in the last sentence here. We can cover this individually with the different models. That's the reason why we have done this modular concept here. All right. Okay, so now we go to the applications. I want to show you some nice applications we have with the WS family. For example, this one. This is a biogas application in Australia. That means if you check this photo behind here, we have normally a gas flame which will burn. Of course, depending on the outside conditions, this can be dangerous for the environment because it can start to burn also the trees and everything. So the WS500 here will regulate if the flame will be on or off. That's also a nice application here for this type of the prevention of bushfires, for example. Then we go on. This one is a Ventus UMB installed in Canada on Whistler Mountain. Whistler Mountain is a very famous local place where normally the people go to ski, right? And of course it's high and they have extreme weather conditions there, and they wanted to know the wind values, and so they installed a Ventus here to regulate the ski lifts and everything. So that's also a nice application. You see that it's really high, all covered with snow. That's a nice application also. Then we have also a nice application in the USA on the AON tower in LA, which is the second highest tower in LA with 262 meters. And they have also installed, you see that here behind, on a WS600, which will regulate different things on the tower, like if there is too much sun, they will regulate the visibility of the sun on the windows and everything, and also the air condition, and all these different things can be regulated with this WS600 here on the top of the tower, right? Then here, this is a picture from China. This is a water quality monitoring system in China where they check the rivers and also the sea, and the sensor here is built up on a boil. And you see they are powered with solar panels. So also this is a special application where you can use WS sensors to measure the environment conditions. Then we have, of course, WS500 here for a solar application. That means solar monitoring. That means solar parks, they need to know the radiation, how strong the sun will the sun power is at that moment, and with this information they can put the panels in the right position, and that's how it works here on this picture. That's the regulation of the solar panels here with the WS501. Then we have here one picture from Germany. That's a fine dust measurement. That means this is also a very important thing in Europe, fine dust, and in the cabinet you will see the fine dust sensor itself, and the fine dust sensor will get the particles from the air. But if the particles are too humid, they cannot measure them. So they need to dry them. And that's the reason for the WS300 here on the left side, because with the information of the WS300, they can activate the drying process of the particles inside a cabinet. That's how it works with this fine dust measurement here, together with our WS300. Then we have here a picture with a car, and that's a mobile weather station. That means this car will drive around different places in the USA, and then they will stop and do actual real-time measurements and send these real-time measurements directly into the cloud. So, and these measurement values are used to do also some forecasts for this special local part here of the USA. And you will see that's the WS600 which is used here, and we have also a precipitation radar system which is not from Luft to check the precipitation, how the precipitation is placed in this region with radar. And that's the last example for today. We are really proud for that. For all stadiums during the FIFA Confed Cup and the World Cup in Brazil, there will be 2 weather stations on each goal side. And they will measure temperature, humidity, pressure, and radiation. And depending on this, they will open here the fans or not. So that's a nice application for us. So if you are really if you are a fan of soccer, next year you can watch the games, and please look behind the goals, because there maybe you will see our weather station standing there measuring all the different weather conditions. Okay, that's a nice project here again in Brazil, which we will have next year, and we are really proud of that. So, questions regarding the complete presentation now? I will also again wait some moment. So how can we find out manual or operating instruction in Luft website? Yes, you will find all the presentations of course on the support section. That means if you open our homepage, you go to the support section, and then on the left side you will have a navigation bar where you can choose what you want to see. For example, you can choose manuals, you can choose also the software and all this stuff. And there you will find everything. So how to install WS stations on the car? Okay, we can go back to the picture and you will see it. On the roof of the car they have installed a small pole. And on the pole they have installed the WS600 here. And again, I have to mention, they will not measure during the car is driving. They will not measure during the car is driving. So they will drive, then they will stop, and when the car stopped, after that they will start the measurements, and then they will put these measurements into the cloud. That's how it works. Okay? So I think that's all for today. I want to thank you for your interest, and hopefully we will meet again in the next webinars. And please check our homepage for all the other webinars which will come in the next months. Thank you very much, and bye-bye.